So let's compare more the E1 and E2 reactions. Again, the E1 mechanism, you have two steps. One is the loss of the leaving group and you form a carbocation, and then deprotonation, the removal of the proton, which forms your double bond. The E2 mechanism is going to be one concerted movement in which we are going to abstract the proton, form the double bond, kick off our leaving group, and in all of this form our final product, and these have to be anti while occurring. So what we've gone over is that for the rate law, an E1 elimination is unimolecular, meaning that it depends only on the concentration of the substrate, while an E2 reaction is bimolecular. It depends on the concentration of the substrate and the base. The big barrier for an E1 reaction is going to be, again, formation of the carbocation. So you're going to see tertiary carbocations and tertiary starting reactants are going to react faster than secondary and then primary, where primary is going to not generally react for an E1 mechanism. E2 does not have a similar big barrier. Now for a base requirement. We talked about this when looking at the differences in switching between a strong versus a weak base. An E1 reaction does not require a strong base and generally is actually driven by a weak base. An E2 reaction does require a strong base to be present. And that's because you have to have this driven mechanism in which a base pulls a proton off. That's part of how we start the E2 mechanism. And thus you have to have something that's strongly basic that can definitely abstract a proton. For stereochemistry, E1 reactions do not have any stereochemical hindrance for the double bond formation. They will follow Zaitsev's rule because the carbocation formation occurs and then you can abstract your proton generally from any area. E2 mechanisms, because they are concerted, because you have this 180-degree requirement of where your proton is and where your leaving group is, because they have to be anti to each other, the stereochemistry will affect the products on an E2 reaction.